Momentum is the strength or force something has when it is in motion or when it is moving. Now, momentum is given by this formula triangle. So we have momentum at the top, mass and velocity at the bottom. So essentially, we can write other equations from this triangle. So of course, if I want momentum, I will cover momentum and I'm left with mass times velocity. So that's mass times velocity. When I want mass, I cover mass. Here, I have momentum divided by velocity. So that's the momentum divided by velocity. And if I want the velocity, I will then have momentum divided by mass. So that's momentum divided by mass. The unit for velocity, as we know, is meters per second, and the unit for mass is kilograms. And that means that the unit for momentum will definitely be kilograms meter per second. Now let us look at an example. So here we have an object of mass 3 kilograms. It's moving with a velocity of 5 meters per second. What is the momentum? Now, because we already have the formula, so the first thing is always to write the formula. So its momentum is equal to mass times velocity. We have identified the mass and we have identified the velocity. So we now just need to insert in the formula, substitute. So that's 3 kilograms multiplied by 5 meters per second. And of course, that is going to give us, that's 15. But of course, we can't forget our units. So that will be 15 kilogram meters per second. Now, for the second one, we have an object of mass 250 grams. And it's moving with a velocity of 100 meters per second. What is this momentum? In this instant, the mass given here is in grams. We need the mass to be in kilograms. So of course we must convert to kilogram. To convert from grams to kilograms, we divide by 1,000. So let's divide this by 1,000. And so let's move 1, 2, 3. So this will give us 0.25 kilogram. And we already know its velocity. So we substitute, so that's 0.25 kilograms multiplied by 100 meters per second. And when we work this out, we are going to get simply 25 kilogram meters per second. When it comes to momentum, there is one thing that may become a bit tricky, and it's the idea of conservation of momentum. Now, as long as no external forces are acting on the objects involved, the total momentum stays the same in explosions and collisions. We say that the momentum is conserved. That simply means the momentum at the beginning is equal to the momentum at the end. And this allows us to find the one entity, say velocity, when the mass is known for one and the mass and velocity is known for the other. So let's look at this example here. So it says a hockey player shoots a 1.5 kilogram puck at 80 meters per second, and that is caught by the opposing team's 65 kilogram goalie. Now we want to know what is the resultant velocity of the goalie who started from rest. So it's essentially at 0. Now, firstly, we have to follow the law. It says initial momentum is equal to final momentum. And the in the beginning, the hockey player that shoots the ball is at 1.5 kilogram. So that's here. And his his velocity is 80 meters per second. So that is outlined here on the left. Now on the right, the goalie, his mass is 65 kilogram. We want to find out his new velocity. So one key thing to do is to rearrange the equations. So if we rewrite the symbol equation below, we know mass 1, velocity 1, and mass 2. We don't know v2, which is velocity 2. So the key thing here is to make v2 the subject of the formula. So what we do is divide this side by mass 2. That will cancel. So we're left with v2. Whatever we do on the right side, we must do on the other side of the equation, or the equal sign. So that's divided also by mass 2. Rewriting, so the v2 then is equal to mass 1 times v1 divided by mass 2. From our scenario, this is mass 1, and this is velocity 1, and this is mass 2, and we don't know the velocity. So all we now need to do is to substitute the entities in the equation. So that's 1.5 multiplied by 80. And of course, the mass for the goalie was 65, and we end up getting 1.85. And of course, because velocity, the unit is meters per second. Quite very straightforward. All you need to do is just rearrange the equation.